Hello friends, welcome back. In this video, we'll talk about how to make flow totalizer. We already make flow totalizer by using SL language. Some of our friends request to make the flow totalizer by using ladder language. So I am making the flow totalizer by ladder language today. Okay. Here see the flow trend, and that flow trends is always changing with time. If the flow is constant like 400 liter per minute, so in 1 minute we can say it is 400, but it is changing with time. So we have to take the value in every changing value, every changing time. So we have to take some sample in this period, within this period in minute. Okay, so our flow totalizer function input should three input, mandatory input. One is the flow rating, okay, second is the period, and this is minute, okay, third is our sampling time. How faster you sample, how faster you sample, uh, that will be your input. And if you take faster sample, your value, totalized value will be more accurate. Okay, now I will add a function block here and give a name as a Totalizer ladder. Okay, and language is C, ladder function. Okay, now here by this arrow, this function block input will be here, that is flow first input, and we'll use the flow data type as a real thing. We will take the flow input 4 to 20 milliamps and scaling by linear or Cyclic or normex function and give a flow as a real. Okay, now here other input is our period, that is liter per minute or TPH, ton per hour. That hour or minute is our periodic time, and it is in time. Okay, now our sampling time, and we can call it as a cycle time. Okay, and our output called it as a total value, total material flow or liquid flow, and that is also real. Here you can see that our output is in real, but input is in real and time. So we have to convert the time to real. Here we will take a function empty box here and name it as a t convert. So t convert is the function that will convert time to integer value. You cannot convert directly to here time to integer, double integer like this. So we have to use the double integer value. If you use the integer value, then you cannot use the periodic time more than 32 seconds, because when you convert time to integer, that time it will convert as a millisecond, because it will convert multiplied by 1000. Okay, so for 32 second it will convert as a 32,000 integer value, and one integer value maximum value is 32768. So you cannot take 32 more than 32 seconds. So if you use the double integer value, you can take more than 32 seconds. Okay, so here is our period time value, but here we have to give a tag here. So here I will declare a tag in static, that period in double integer period in real, cycle in din, cycle in real. Okay, now here since data type din real din real. Okay, now here give a tag as a period as a din. Here I will take another empty box and give us a name as a conversion. This conversion function will make the double integer value to real. Okay, here period in real, so it will convert double integer to real, and we can name it as a period prime to real. Okay, and here we will take cycle prime to real. Okay, same as here we'll take empty box, and you can where that time conversion function is located, it is located in the extended instruction in the date and time of day. Here this is our t conversion function. Okay, t conversion function only you can use for ladder in CPU S7 1200 and 1500. If you use S7 300 400 CPU, you cannot use the T conversion function in ladder. You can use in SL language T conversion, and here D into conversion function. Okay, now here cycle time as input, output is cycle in din, and here input as a cycle in din, and here output is cycle in real. Okay, so our conversion is complete. Now all the input is in real data type. Now we have to convert flow unity, that our input flow maybe is in liter per minute, liter per second, or ton per hour, like this. So if we divided that flow value by the period, then it will be in unity. Then if we multiply it by the sample, then we will get the total value. Okay, now I will take a empty box, give a name as a division. Okay, so here our input of the division value is flow. Okay, and we will divide it by the periodic real value. Okay, and keep it as a here as a, give a name as a flow unity value, and that is in real. Okay, here we'll keep the division value in the tag, and then we will multiply it by that flow unity value, with the cycle real value. Okay, then it will be our total value, total in one cycle. Okay, one total in one cycle. Okay, if you not use another variable, then every time it will send. So we have to add every time this value with another static value. So here we'll add our static value. So our output is total, and that total here total will add with total in cycle. So every time add total in cycle with that total. Okay, and when it will add, okay, I will use another input as a measure on that. Sometime the motor is running or belt is running, that time it will calculate, because sometimes some milliamps will come as a 1 ton per meter, 1 tps 2 tps, that time it will also adding. So we'll add a another input, that is measure on, and that measure on will work. Measure on input will be belt run or other input as your application. So here this one will add when measure on is there. Okay, measure on, when measure is on, that time the value will add with total. Okay, now you have may there is another input, that is reset. Sometimes you may require to reset your total value. So here we will add another tag, that is reset. So when we will give a command by the reset, that time that total value will be 0. Okay, now giving a reset here, reset. Okay, then we'll give a move command, that will 0 to 0 to that total value, total. Same way we'll add, also we have to, because some value is there also, so we have to give a 0 command to that tag also. Okay, here move that 0.0 to 0.02 to that total in one cycle value. Okay, when the reset is generated, that time there should not be any addition value there. So only the addition will be work when there is no reset command. So reset command is with that addition value. Okay, now this is our application function. This is our function for totalizer. You can give another input, okay, that is not. So here we'll use another tag, give another input, but it will not use for calculation. It is just for define the totalizer name, because sometimes you may have more than one totalizer. So which totalize for which one, you can define by the totalizer name. So the data type is string. Okay, now this is our all function. Okay, you may now call this function to OB1, main OB1 or any other FC function. Okay, now I will call, okay, here this is our totalizer in ladder. Here we'll give a just a name, that input. If it is in here you have to give a inverted comma, that input flow total. Okay, now measure on, and this measure on you have to give a when it will measure. there I will take a data block that is give a flow total data block name. Here I will give a name that is okay, reset okay, flow total, and one input is reset. And cycle time, if you use the clock memory, then you have to use as fast sample you have, and it is only 100. Okay, if you go to the device here, go to properties here, in system and clock memory, you can see that I have enabled the clock memory bit. Clock memory bit is MB1 byte 1, and MB0 1.0 is our fastest cycle, and it is 110 hertz, means 100 millisecond pulse. Okay, we'll use that one. This is the fastest clock memory we have. Okay, we'll also use that function, totalizer function, in cyclic interrupt, that will more faster than that clock cycle 100 millisecond. So first we'll use that clock cycle here. So fastest clock cycle is 100 millisecond, that is 10 hertz, so we have to use 100 millisecond. Okay, cycle time. If you have the flow is in second or minute, so think it is in minute, so 1 minute. Your time is periodic time is 1 minute. So here I will give a tag flow, it is in real. Okay, it is in real, so here I will use a flow total flow here. So which one will be measure one, and that is, suppose I will use a pulse. Think that is a belt on. You may have a belt on function. So think this is a belt on or motor on. Motor on bit from somewhere else. So flow motor on. Okay, maybe this is in real, so it is not showing. Sorry, bull. Motor on. Okay, input. Then I will take the fastest clock bit, that is M1.0. okay, so this clock bit will stay for 100 millisecond. It will come in every 100 millisecond and stay for 100 millisecond. So it will add for 100 millisecond, but your CPU cycle time may be 1 second. So in one pulse, for one pulse it will add 100 times. So we will give a one shot logic. Okay, one shot logic that will, if the input is came for once, it will give only once. So here we will use a memory bit as a one shot, total one shot. Okay, measure one shot, and that is bool. Here we will use flow measure one shot. Okay, this is our all things. Now we'll download. In second video we'll use the cyclic interruption function that will okay, Okay, in cyclic interruption function we will use for totalizer that will give more faster scan. It is for 100 sampling time for 100 millisecond. If we use the cyclic interruption function, that will give more faster sampling, maybe 2 3 5 100 or any time. I will show in next video. Okay, now see, it is showing 0 because our flow is 0. Now here I will make it. Okay, sorry, no need. Here I can just modify the value. Okay, if the flow is 20, so for 1 minute it should be 20, it should be 20 in total. If we now measure on, suppose motor is on, now flow is coming and it is now adding, so after 1 minute it should be 20. This is our flow totalizer by using ladder language, and keep in mind you cannot use the ladder language for 7300 400 CPU. It will only available for 1200 1500 series PLC. Okay, thank you.